Mathematics is the silent language that shapes our modern existence. We may not always see it, but its influence is everywhere. It is the invisible force that guides our daily lives, from the mundane to the monumental. Consider the device you are using to read this. Its design, its software, and the network that delivered it to you are all built upon a foundation of complex mathematical principles. Even something as personal as finding a partner has been handed over to algorithms. Matchmaking apps use sophisticated equations to analyze your preferences, your behaviors, and your personality traits. They then compare this data with millions of others, all to predict who might be your perfect match. It is a strange and wonderful thought. Our search for love is now guided by the cold, hard logic of mathematics. This hidden architecture extends far beyond our personal devices and social lives. It is the bedrock of our global economy, where financial markets rise and fall based on mathematical models that attempt to predict human behavior and economic trends. It is the tool that allows engineers to design bridges that defy gravity and skyscrapers that touch the clouds, ensuring they can withstand the forces of nature. When you step onto an airplane, you are placing your trust not just in the pilot, but in the countless calculations that govern its aerodynamics, navigation, and structural integrity. Mathematics is the guarantor of our safety and the engine of our progress. It is the reason our world works the way it does, with a precision and reliability that we often take for granted. Even our understanding of the natural world is mediated through the lens of mathematics. When scientists seek to unravel the mysteries of the cosmos, from the smallest subatomic particle to the largest galaxy, they do so using mathematical equations. Physics, chemistry, and biology have all become deeply mathematical sciences. The models that predict climate change, the formulas that describe the spread of diseases, and the genetic codes that define life itself are all expressed in the language of numbers and symbols. In this sense, mathematics is not just a tool for building things, it is our primary means of understanding the very fabric of reality. It gives us a framework to ask questions about the universe and a method for finding coherent, testable answers. We live in a world that has been profoundly shaped, ordered, and interpreted by mathematics. Yet for many of us, the subject remains a source of anxiety, a collection of abstract rules and dry formulas learned in school. We fail to see the elegance and power behind the equations. We miss the story of how this incredible intellectual tool came to be, and the deep philosophical questions it has raised throughout history. How did humanity come to possess such a powerful key? And what does its remarkable ability to describe our universe tell us about the nature of reality itself? This journey from ancient certainty to modern mystery is a story worth exploring, for it touches upon the biggest questions we can ask. The story of mathematics begins not in the lofty halls of academia, but in the muddy fields of ancient civilizations. It was born from necessity. The earliest humans needed to count. They needed to count their flock to know if any sheep were missing. They needed to measure their land to divide it fairly after the annual floods of the Nile or the Tigris. They needed to track the seasons to know when to plant their crops and when to harvest them. The Sumerians, Babylonians, and Egyptians were brilliant practical mathematicians. They developed systems of counting, basic arithmetic, and simple geometry to solve the pressing problems of their daily lives. Their mathematics was a tool for survival and for organizing society. These ancient cultures were driven by practical needs. The Babylonians, for instance, were meticulous astronomers. They charted the movements of the stars and planets with impressive accuracy. They did this not out of pure scientific curiosity, but for astrological and religious purposes. They believed the heavens held clues to the future and the will of the gods. To do this, they developed a sophisticated number system based on 60, the legacy of which we still see today in our measurement of time and angles. Similarly, The Egyptians used geometry to build their magnificent pyramids and temples, structures that required precise measurements and an intuitive understanding of spatial relationships. Their mathematics was entirely concrete, tied directly to the physical world they could see and touch. However, for these early civilizations, mathematics was not yet an abstract discipline. It was a set of recipes, a collection of procedures that worked. They knew how to calculate the area of a field or predict an eclipse, but they were less concerned with why these procedures worked. There was no concept of a formal proof, no desire to build a system of logical axioms from which all other truths could be derived. Mathematics was a practical art, much like pottery or metalworking. It was a means to an end, whether that end was building a monument, dividing inheritance, or managing the state's granaries. The idea of numbers or shapes existing as pure concepts, independent of any physical object, had not yet taken hold. This practical foundation was the essential first step. Without the Babylonians' astronomical tables or the Egyptians' rules for land measurement, the next great leap in mathematical thought would not have been possible. These civilizations laid the groundwork by demonstrating that the world contained patterns and regularities that could be described with numbers. They showed that a quantitative approach to reality was fruitful, but it would take a different kind of culture, one obsessed not just with practical application but with reason and universal truth, to transform mathematics from a useful tool into a profound system of abstract thought. That leap would be made by the ancient Greeks. It was the ancient Greeks who revolutionized mathematics, transforming it from a practical handbook into a discipline of pure reason. Thinkers like Pythagoras, Euclid, and Plato were not content with knowing that a formula worked. They wanted to understand why it worked. They sought universal truths that were certain and eternal. For them, mathematics was the purest form of thought, a pathway to understanding the fundamental nature of reality. The Pythagoreans, for example, believed that all is number. They saw mathematical relationships not just in shapes and figures, but in the harmony of music and the motions of the planets. For them, the universe was a cosmos, an ordered and beautiful whole, governed by numerical principles. This quest for certainty led to the invention of the mathematical proof. The Greeks were the first to insist that mathematical statements must be proven through a sequence of logical steps, starting from a set of basic assumptions, or axioms. The most famous example of this is Euclid's Elements. This monumental work was not just a collection of geometric facts, it was a complete logical system. Starting with just a handful of definitions and postulates, Euclid derived hundreds of theorems with irrefutable logic. For over 2,000 years, his work was considered the absolute model of rigorous thinking. It showed that the human mind could access a realm of perfect, unchanging truth, far removed from the messy and deceptive world of the senses. This abstract turn had profound philosophical consequences. Plato, for instance, argued that mathematical objects like perfect circles or ideal triangles existed in a higher spiritual realm of forms. The circles we draw in the sand are just imperfect shadows of the one true, perfect circle. By doing mathematics, he believed, the soul could be purified and turned away from the fleeting world of appearances toward the eternal world of truth. Mathematics was therefore not just a mental exercise, it was a spiritual discipline. It was a way of training the mind to see beyond the physical and grasp the underlying intelligible structure of the universe. This elevated mathematics to the highest form of knowledge. The Greek achievement was to sever mathematics from its purely practical moorings. They created a world of abstract ideas, a universe of numbers, shapes, and proofs that could be explored for its own sake. They established that the human intellect, through reason alone, could discover timeless and universal truths. This was a radical and powerful idea. It laid the foundation for Western science and philosophy, embedding the belief that the universe is fundamentally rational and can be understood by the human mind. The Greeks did not see mathematics as a human invention, but as a discovery of a pre-existing reality. The order was already there. The mathematician just had to find it. With the rise of Christianity, the Greek love for rational order found a new and powerful context. Early Christian thinkers like Augustine saw the mathematical elegance of the universe not as an abstract principle, but as a direct expression of the mind of God. If the world was created by a rational and omnipotent creator, then it must reflect his nature. It must be ordered, consistent, and intelligible. Mathematics, in this view, was the language God used to write the universe into existence. The order that the Greeks had discovered was not some impersonal cosmic force. It was the fingerprint of a personal, intelligent designer. Faith and reason were not enemies. They were partners in the quest to understand God's creation. This synthesis of Greek philosophy and Christian theology became a cornerstone of Western thought throughout the Middle Ages. Scholars in monasteries and the newly formed universities studied both scripture and the classical works of Euclid and Plato. They did not see a contradiction. For them, studying the mathematical harmonies in nature was a form of worship, a way of appreciating the wisdom and artistry of the Creator. Boethius, a 6th century Christian philosopher, placed mathematics at the heart of education, arguing that it disciplines the mind to perceive the divine order that underpins all things. The universe was seen as a great book, and mathematics was the key to reading it. This view saw God not as an arbitrary ruler, but as the ultimate source of logic and reason. This had a profound implication. It meant the universe was not chaotic or governed by the whims of unpredictable deities, as many pagan religions believed. Instead, it operated according to fixed, reliable laws. These laws were put in place by God, and because we are created in His image, with rational minds we have the capacity to discover and understand them. This theological conviction provided a powerful motivation for scientific inquiry. It gave scholars the confidence to believe that the natural world was worth investigating and that its secrets could be unlocked through careful observation and logical reasoning. Therefore, the pursuit of mathematics during this period was never just about numbers. It was a deeply theological enterprise. It was about tracing the lines of God's grand design, the geometric patterns in a snowflake, the predictable paths of the stars, the pleasing proportions in art and architecture. All were seen as echoes of the divine mind. This worldview, which integrated faith, reason, and mathematics, created the fertile intellectual ground from which modern science would eventually spring. The scientists who would later spark a revolution did not see themselves as rebelling against this tradition, but as fulfilling it by using mathematics to reveal the glory of God's handiwork in ever greater detail. The scientific revolution was not, a rebellion against faith, but actually its logical culmination. The great pioneers of this era, Copernicus, Kepler, Galileo, and Newton, were devout men who truly believed they were using mathematics to uncover the laws God had ordained for His creation. Nicholas Copernicus, who proposed that the Earth revolved around the Sun, did so not to dethrone humanity or anything, but because a heliocentric model just seemed more mathematically elegant and harmonious, more befitting of a wise creator. He was searching for the true, God-given structure of the cosmos, and he believed mathematics was the key that would unlock it. His work was, in a sense, an act of intellectual worship. Johannes Kepler, a brilliant astronomer and mathematician, took this even further. He was driven by a deep conviction that God was a geometer. He spent years trying to fit the planetary orbits into a model based on the 5 perfect Platonic solids, convinced that this would reveal God's beautiful architectural plan for the solar system. While that specific idea turned out to be wrong, his relentless pursuit led him to his 3 famous laws of planetary motion. He discovered that planets move in elliptical orbits, not perfect circles. But he did not see this as a flaw, but rather as a deeper, more subtle harmony. He famously wrote that in his work he was merely thinking God's thoughts after him. Galilei continued this tradition, famously stating that the book of nature is written in the language of mathematics. With his telescope, he saw the moons of Jupiter and the mountains on our own moon, confirming that the heavens were not some ethereal, perfect realm, but a physical place governed by the same laws as Earth. He used mathematical analysis to describe the motion of falling objects, showing that the physical world behaved with predictable, quantifiable consistency. For Galileo, to do science was to decipher the mathematical script in which God had written the rules of the universe. His clashes with the church were not about science versus faith, but about how scripture should be interpreted in light of new scientific discoveries. The climax of this era came with Isaac Newton. His is perhaps the most important scientific book ever written. In it he laid out his laws of motion and the law of universal gravitation in the rigorous axiomatic style of Euclid. With a single, elegant mathematical equation, he could explain both the fall of an apple and the orbit of the moon. It was, honestly, a breathtaking synthesis. Newton demonstrated that the entire universe, from the smallest projectile to the grandest celestial body, operated according to a single set of precise mathematical laws. He firmly believed that this magnificent clockwork system could only have been designed and set in motion by an intelligent and powerful being. For Newton, science and mathematics were the ultimate testament to God's genius. For centuries, the system built by Euclid and perfected by Newton seemed unassailable. Mathematics was the bedrock of truth, the one language that described reality with absolute certainty. Euclidean geometry, with its simple axioms about points, lines, and planes, was not just a useful model, it was considered the true geometry of space. The universe, it seemed, was built on a Euclidean blueprint. However, in the 19th century, this unshakable confidence began to crumble. Mathematicians started to question one of Euclid's foundational axioms, the parallel postulate, which states that through a point not on a given line, only one parallel line can be drawn. What would happen, they wondered, if this were not true? This line of questioning led to a shocking and revolutionary discovery, the creation of non-Euclidean geometries. Mathematicians like Bolyai, Lobachevsky, and later Riemann demonstrated that it was possible to construct perfectly consistent geometric systems where the parallel postulate was false. In these strange new worlds, the angles of a triangle might add up to less than 180 degrees or more. Suddenly there was not one true geometry, but many. This sent a shockwave through the worlds of mathematics and philosophy. If Euclid's geometry was not the only possible one, how could we be sure it was the true one? And if we couldn't be certain about the nature of space, what could we be certain about? The crisis deepened in the early 20th century with the work of the logician Kurt Gödel. He delivered another devastating blow to the dream of mathematical certainty with his incompleteness theorems. Gödel proved that in any consistent formal system of mathematics powerful enough to describe basic arithmetic, there will always be true statements that cannot be proven within that system. In other words, mathematics itself is inherently incomplete. There will always be mathematical truths that lie beyond our ability to prove them. This discovery shattered the hope held by many mathematicians that they could one day create a complete and final theory of everything in mathematics. These developments created a profound sense of unease. The old view of mathematics as a pristine window into a realm of divine or absolute truth was no longer tenable. The foundations had been shaken. If mathematics was not a single certain truth, then what was it? This crisis led to a split in how people thought about the nature of mathematics. It lost its privileged status as the language of God or the blueprint of reality. Instead, it came to be seen in a new, more humble, and perhaps more troubling light. The age of certainty was over, and the age of modern mathematical mystery had begun. In the wake of the crisis of certainty, two dominant philosophies emerged to explain what mathematics is. The first is known as formalism. This view holds that mathematics is essentially a sophisticated game, played according to strict rules. The symbols we use, like numbers, variables, and operators, have no inherent meaning. They are just tokens on a board. A mathematician is someone who manipulates these symbols according to a set of agreed-upon axioms and rules of inference to create theorems. A proof is simply a valid sequence of moves in this game. Whether these theorems correspond to anything in the real world is a separate and less important question. This perspective effectively strips mathematics of its soul. It detaches it from the profound sense of discovery that had motivated mathematicians for millennia. In the formalist view, mathematicians do not discover pre-existing truths, they invent them. The elegance of a proof or the beauty of a theorem is reduced to mere cleverness in a formal game. This approach is useful for ensuring rigor and avoiding contradictions, but it fails to explain one of the most astonishing things about mathematics: its incredible power to describe the physical world. If math is just a game, why are its rules so perfectly suited to explaining everything from quantum mechanics to the expansion of the universe? The second major viewpoint is instrumentalism, or pragmatism. This is the perspective of many working scientists and engineers. For an instrumentalist, the philosophical questions about the nature of mathematics are irrelevant. What matters is that it works. Mathematics is simply a useful tool, a kind of intellectual toolbox. If an equation helps you build a better bridge, launch a satellite, or model a financial market, then it is a good equation. The question of whether it is true in some deep metaphysical sense is a distraction. Mathematics is valued for its utility, for its power to predict and control the world around us. While immensely practical, this view is also philosophically unsatisfying. It leaves the central mystery completely untouched. It celebrates the usefulness of the tool without ever asking why the tool is so perfectly crafted for the job. It is like finding a key that happens to unlock every door in the universe and being content to simply use it without ever wondering who made the key or why it fits. By reducing mathematics to either a meaningless game or a mere tool, both of these modern viewpoints sidestep the deeper questions that have animated its history. The connection between the abstract world of mathematical ideas and the concrete reality of the cosmos is left as a lucky coincidence. This brings us to the heart of the modern mystery. The physicist Eugene Wigner, in a famous essay, called it the unreasonable effectiveness of mathematics in the natural sciences. Why should the universe obey rules that can be expressed in the language of mathematics? Why do abstract concepts, often invented by mathematicians with no thought for practical application, turn out to be the perfect tools for describing reality? Think of the complex numbers, which involve the square root of -1. They were initially seen as a purely mathematical curiosity, an abstract fiction. Yet today, they are absolutely essential for the equations of quantum mechanics, the theory that describes the fundamental reality of our world. This phenomenon occurs again and again throughout the history of science. The non-Euclidean geometries that seemed like strange, abstract games in the 19th century turned out to be precisely what Albert Einstein needed a century later to formulate his theory of general relativity. His theory describes gravity as the curvature of space-time, a concept that is inherently non-Euclidean. It seems that the human mind, playing with abstract logical structures, keeps stumbling upon the very concepts needed to unlock the secrets of the universe. This is a profound puzzle. Is it just a massive coincidence? Or does it point to something deeper about the relationship between our minds and the cosmos? The puzzle becomes even more acute when we consider that mathematics is a product of the human mind. How is it that our minds, which evolved for survival on the African savanna, are capable of generating concepts that describe the inner workings of an atom or the birth of the universe, if our minds are simply the product of a blind, unguided evolutionary process, there is no reason to expect that they should be capable of understanding the deep structure of reality. Charles Darwin himself expressed this doubt, wondering if the convictions of a man's mind, which developed from the mind of lower animals, are of any value or at all trustworthy. This unreasonable effectiveness is a mystery that the dominant modern philosophies of mathematics, formalism and instrumentalism are ill-equipped to answer. If math is just a formal game, its connection to reality is a miracle. If it is just a tool, we have no explanation for why the toolbox we invented happens to contain the perfect instrument for every cosmic job we encounter. The fact that the universe is not only ordered but ordered in a way that is intelligible to us, that it is written in a language our minds can speak, demands an explanation. It suggests a deep underlying harmony between the internal world of human thought and the external world of physical reality. There is another way to look at this mystery, an explanation that reconnects mathematics with its rich, historical search for meaning. From a Christian perspective, the unreasonable effectiveness of mathematics is not unreasonable at all. It is exactly what we would expect. The reason mathematics works so well is that the universe was created by a rational, intelligent God. The order we find in the cosmos is not a brute fact. It is the product of a divine mind. The physical laws that govern the universe are a reflection of his logical and faithful nature. The universe is mathematical because its creator is the ultimate mathematician. Furthermore, this perspective explains why we are able to understand this order. The Bible teaches that human beings are made in the image of God. This does not mean we look like God physically, but that we share, in a finite and limited way, some of his attributes. These include creativity, morality, and, crucially, rationality. God created us with minds capable of reason and logic, minds that are tuned, in a sense, to the same frequency as the universe he created. We can understand the universe with mathematics because both the universe and our minds are the product of the same rational source. The harmony between our thoughts and the world is not a coincidence, it was intended. This view restores a sense of wonder and purpose to the pursuit of mathematics. It is no longer just a dry, formal game or a purely utilitarian tool. It becomes, once again, a profound act of discovery. When we do mathematics, we are not inventing arbitrary rules. We are tracing the patterns of thought of the Creator. We are exploring the intricate and beautiful logic that underpins the fabric of his creation. This imbues the subject with a dignity and significance that the modern philosophies have lost. It invites us to see the elegance of a theorem or the power of an equation as a glimpse into the divine artistry woven into reality. Therefore, I invite you to see mathematics in a new light. Look beyond the facts and formulas you may have learned in school. See it not as a barrier, but as a gateway. It is a creative and deeply meaningful pursuit that reveals the fundamental structure and breathtaking beauty of the world. Whether you are a student, a scientist, an artist, or simply a curious person, mathematics offers a unique window onto the truth and order of creation. It is a powerful testament to a universe that is not a random accident, but a coherent, intelligible, and magnificent cosmos waiting to be explored and understood.